Hey class, I'm back. I am just doing this last part of 4.3 for you. The other part we'll do in class. But this is the part about inverses, and I taught this in 4.1, right? When we were trying to find out if two functions were inverses of each other. So that's the same thing that we're doing here. If f of x and g of x are inverses, the following is true. Remember, I said this to you all too, that if you go this way, well, I write it this way because I like it old school way. Then it has to equal to x. Remember that it has to equal x. Or if you write it this way, right here, remember it had to equal x. So this is what we're doing. Plugging one function into another function, and if they both come back x, you got to do it both ways. And when it comes back, it has each way has to come back x. It cannot come back to anything else but x, 1x. It can't be 10x. It cannot be x squared. It cannot be 1. It cannot be 0. Each way has to come back to x, which is understood to be 1x. If it does not come back to 1x, you prove that they are not inverses. Okay? That's all you're proving, that they're not inverses of each other. If they're going to be inverses of each other, you all, it will come back to x. Okay? It'll come back to x. Now, we're doing this with logarithm and exponential function because they are inverses of each other. But we are going to prove with certain functions right now. And like I said, we did this in 4.1, so this should be a review for you all on this end. Okay. And once again, if go ahead and copy this down, you all, because remember I gave this. I write it this way. You know I talk about it. Because with this way, you can see what function needs to go into the other function. Like this needs to go into that. That's why I write it this way. But this is the formal way to write it. These are the formal way to write it. And I want you to know what's the formal way. Okay. I like the old school way because it shows me what goes into what. Right. So that's the way I'm going to be writing it when I do the work. Okay. So let's what it says. Use the property of inverses to determine whether f and g are inverses. And this is what I mean by using the property of inverses. Just show both ways give you x. That's what it wants to know. If both ways give us x, you all, then they're inverses of each other. If both ways does not give us x, one way give us x and one way give us another thing, then they are not inverses of each other. As simple as that. Okay. So use the property of inverses to determine whether f and g are inverses. That's all we're trying to do. Are they inverses? They should come back to x either way. Okay. So now let's do it. Right. I'm doing it the first way. F of g of x. Right. And what I'm doing is I'm plugging in g of x right here into this function. Is everybody with me? So I'm taking all of this, and where I see x, which is right here, that's where I'm plugging in at. That's how I'm doing this function. Okay. Now, let's do it. Okay. So I'm saying my f function, let me write down f log base 3 of x. Y'all see that, right? But my x is now g of x. So let me put that in parentheses because this is what I'm plugging in. I want everybody to see what I'm plugging in. Okay. Now, you all, we're plugging it in. I have taught you now about some properties, but let's go back to this property that I've taught you about. Okay. Go back to the property here. And that is these properties right here. This one or this one. Well, right now we're looking at this property right here, number 3. That if I have log base a of a raised to the x, that just gives me x. Let me say it again. Log base a of a raised to the x give me x. Why? Log base a, and then you have an exponential of that same base. They cancel each other out, leaving you what's here. Okay, let me say it again. When you have log base a, just a reminder, log base a of a, which is the base raised to an x, These cancels each other. These are inverses of each other. They cancel each other out, just leaving you what's here. So let's go back here. Let's go. These would cancel each other out. This log base 3 will cancel out this right here. That's what would happen. When you cancel that out, you're left with this. But look what we have on the outside. We have 4. So let's write this. We get 4 times what is left, which is x over 4. What cancels each other out now? This, leaving us with just x. Okay. So we get x this way. You got those properties that I showed you earlier. You're going to have to, when I teach it to you, you will know how to do it, okay? By the time you get this video, it'll be after I taught that. But you will have to know that property. I don't give that property. You have to study those properties. You have to know them. That a log of that base and then the same base for an exponential, they cancel each other out, okay? Now, you all, let's go the other way around. I want to write it over here. Sorry. Let me do it. Yeah, sorry, I want to write it right here. So I want to see g of f of x, sorry. Now, y'all see f of x is going into g, right? So let me erase this real quick. Let me do this and this, because we're not doing that. Now, all of this, you all, just trying to show you, all of this will go in right here where x is. Y'all see that, right? Just trying to show y'all how it's going to be written. So let's do it. When I plug it in, we get 3 raised to the, see, it's a power, right? So 3 raised to the, right at the very top of that power, which is the x, I got to put f of x in there, okay? So let's do it. We're going to do right here, because this is the power, 4 log base 3 of x over 4, okay? Because that's the power, right? I'm putting that f of x right here, like I'm supposed to. Now, when we put f of x there, and I'm doing different colors so you see what I'm plugging in right there, right? And no, what I should have done was put, this should be here, sorry. Because you didn't have to plug that in. You just plug the top in, sorry. To make it easy. Yeah, you just had to plug the top in. Now, when we do this, you all should automatically see what cancels on in the exponent. Y'all see these 4's cancels, right? Y'all see that? And then we're left with what? 3 raised to the log base 3 of x. Well, if you go back to that law that I said, there's a law that says a raised to the log of base a x gives me x. That's what that property says. Because if you have an exponential of that base and then you have a log of the same base, they cancel each other out, so it'll leave you with x. That's the property. Okay, so look what happens here. This 3 cancels log of 3. And now you're left with x. Okay. So I hope that, and you have to use those properties, you all. You have to use